need your love. No babysitting other engineers, no fixing the same bugs over and over again, no working on stuff you have minimal impact on. Just pure engineering as you love it.
What is up, everyone? In this video, I'm going to give you an introduction into the actor model, specifically in Golang. I think the actor model is a very undereducated model, a very undereducated paradigm, although, don't get me mistaken, it's getting used in the industry big time, right? It's especially all these highly concurrent applications, RTS games, the actor model, even in gaming game service, is getting used by a long shot, right? So it's very important to know that, especially for the people that write in Go, because Go is very high concurrent, and I think Golang has a very, very good place for the actor model. But before we continue, if you like the videos that I'm providing to you, please consider subscribing, because still 49% of my viewers are not yet subscribed, and it's just one click away, and you can do me an enormous favor, because I don't have any sponsors, I don't have ads, it's all, hey, it's all for free, right? But especially, consider subscribing to my channel. Also, jump into my Discord community. Very important if you want to get help and all that stuff. 24/7 open for business, right? For the people that really want to level up as a Go engineer, go to the Patreon, check it out. It's very exclusive videos. In that topics, a little bit of more advanced. And for the people that basically want to learn how to write Golang, for their job, they want to basically be a backend Golang engineer. I'm reopening the full-time GoDev.com course, which I actually started, but then I canceled it. But because so many people are asking me to open it, to continue it. After this video is open for enrollment. There is a discount. Check the link. And by the end of April, it's 1 month from now, everything will be uploaded. All the chapters. It's going to be huge. It's a huge course. It's everything. It's the basics of Go concurrency, interfaces, all that stuff. It's going to have JSON APIs, microservices, Docker, and you have a complete blockchain from scratch in that completely, that's not available on the internet. All in the full-time GoDev course. Check it out. Mail me or DM me if you want to have more information about it. All right, without any further ado, let's continue the actor Golang model. So what I'm going to do, I have this small folder here. It's called GoAct because, yeah, I have no inspiration. So what I'm going to make a new file. It's going to be main.go, just like that. And we're going to, first of all, I'm going to show you something, right? So let's make it here. We're going to say type. There's going to be a handler. Yes, a handler is fine. That's going to be a structure here. The font is huge, not line. And we're going to have a state, right? And that state is going to be a uint. Very simple, not too complex, right? And we're going to have a function here, for example, func. I need a new PC because each time I record, it's like fuck. So we're going to say handler, and we're going to say handle message, right? Very simple, handle message, and the message is going to be a uint. And what we're going to do is basically, we're going to say state equals msg and call it a day, right? So the problem is basically that each time, age.state, by the way, guys, my bad. The problem with that is in a concurrent environment, the handle message of this handler is going to get called each time it receives a message, for example, in gRPC or HTTP or whatever, and it's going to be handled in its own Go routine most of the time, right? So that's the first problem that already arises, right? If you have a game server or something, you want to update player health, it's going to get called inside of a tick, inside of a loop, inside of a Go routine, right? So let's see what's going on. So let's make this handler real quick. We're going to say handler here, and then we're going to say for I equals 0, I smaller than 10, for example, I plus plus, and then we're going to actually do h handle message, and then we're going to do y. Actually, it needs to be a uint. Just like that. Boolean expressions going on here for I, yada, yada, yada. This one is a problem, not anymore. Just like that. So if we save this and then we do go run main.go, you don't see anything. Actually, to be honest, we're going to say go run --rate main.go. So nothing is going to happen. It's all fine because this is getting called each time after time, right? The state will be basically incremented, and not incremented, it will be set by the iterator each loop in a synchronous way, so there's no way to have race conditions. The problem will be, the problem will arise if you do go, right? Then we're going to have some shenanigans going on, right? You see, because we're updating our state all at the same time-ish, right? It's of course the Go scheduler will, it's not at the same time, it's not in parallel, but you know what I'm trying to say here. So we're going to have a race condition. So you could already see that our handler here, it could be a player, it could be whatever you want. This state is not safe anymore to use. So how could you solve that? Well, in a classic programming, what we do is we add a lock, right? We do a sync mutex or something here, and then we could lock our state each time for reading or for writing or for both. And sometimes we're going to lock it at a certain point in our code, and maybe we forget to unlock it, and maybe things are waiting for the same lock. And especially in these highly concurrent messages in a game server, for example, I always say game server because it's a very good use case, a very common use case. There are a lot of updates going on, and it could be that your program is basically not exhausted, but it's slow because everybody's waiting for locks, and it's nasty, hard to debug. It's just, you're gonna have a bad time, right? So how can we fix that, right? There is something that's called the actor model, the actor paradigm, and it's basically it's the principle of the mechanics, the semantics of the actor model is that every piece of entity, something that can act on something, that's why the actor model, because you're going to act upon messages, right? Everything that needs to handle a state, everything that can receive some kind of a data, it's very data-oriented approach, it will basically handle that message after message, right? It's not gonna. It's going to be, if you send it 100 messages, it's basically going to handle each like a queue. Exactly. I can a long time. I'm choking. I'm gonna lie. I'm choking today. It is what it is. Sometimes I'll also choke. So basically, it's going to handle these messages one by one. That's maybe a better approach. So there is no need to lock it. So I'm gonna give you an example. So let's refactor this handle into a Hollywood, which is an active framework for Golang. The only thing you need to do. Let me actually open it up. Can I do this without causing news to be leaked? Let me go GitHub. Boom, just like this. Look at this guy here. Let's bomb this up. Where is? How do I do this, man? What's going on here? What's going on? Where are my settings? Here, right? And we're going to Hollywood here, boom, just like that. And this is basically the framework, the actor model framework, basically fast, low latency, access, blah, blah, blah. What is the actor model? Read it, features, nice documentation, and all that stuff. That's what we're going to use, right? So basically, how do we install it? Very simple. Let's clear the screen. We're going to say go get github.com, right? And VM, that's me. And then I'm going to say Hollywood, boom, just like this. And it's probably already been done. Let me see in my mod file here real quick. What's going on in VT Protobuf? Can we do go mod tidy real quick? TD. Nothing happened. It's all good. It's all fine. Right? So what we're going to do first is we're going to transform our handler into a receiver, right? An actor or a receiver. In Hollywood, it calls a receiver and not actor because we are just receiving, right? It makes sense. So the first thing we're going to do is we're going to make a function here. Let's copy this. Just like that, and we're going to call this function receive. That's something we need to implement, right? We're going to receive here, and the message is going to be any. It could be anything we want, and we're going to say, we're going to switch here, switch message, based on the, it's not, I'm so wrong, it's going to be context. I'm not on point today, not going to lie. Actor context, by the way. Actor context, just like that. So we're going to basically switch here on the message, the context message, and we're going to switch on the type, right? And by default, each time you're basically going to boot up, if the engine is going to spin up your actor, what's going to happen is that the system itself, the engine itself, is going to send messages to your actor, so you know it started, you know it stopped, you know it's initialized and all that stuff, right? So we could already say case actor started, just like that. Then we're going to say case actor stopped, right? If your actor is stopped, you're going to get a stop message. If your actor is started, you're going to get the started message. And if your actor is initialized, you're going to get the initialized message, right? So we could say here fmt println, by the way, we're going to say my actor, basically handler started, handler started, just like that. And we could say basically, it's maybe a nice thing to do each time. Actually, to be honest, let's do it in initialized, right? Handler initialized, and we're going to say my state, and my state is going to be h state, just like that. And we're going to actually initialize the state with some value. We're going to say state is 10, right? State is 10, that's fine. Let's do this for the compiler real quick here, so we don't have any problems. So basically that's that. The next thing we're going to do is handle message. We're going to basically delete this stuff, right? We don't need it anymore. The next thing we're going to do here is we don't need this for loop anymore, and we don't need this, actually, to be honest. The first thing we need to do is make a kind of a constructor for our handler. So we're going to say func new handler, and that's going to return an actor receiver, right? And we're going to return basically just a pointer to ourselves, handlers. Just like that. Boom, that's fine. The next thing we're going to do here, and let me scroll up the screen here real quick. We're going to make a new engine, right? We're going to say actor new engine. Very important. The engine is basically something that handles and tracks and manage basically all of our shebang here. Just double checking if I'm recording, because it's not the first time that I'm basically talking gibberish for nobody, right? So we're going to say actor new engine, and this engine is basically has the capabilities of spawning stuff, right? So we're going to say engine spawn me. We're going to call engine spawn. We're going to say new handler. And I'm going to call this handler, or my handler, or whatever you want. And this spawn method is going to return a process ID, right? Let me print out the process ID real quick. We're going to say fmt println bit do this, maybe this, and this, right? So let's do the rest. Can be, it's fine. So you can see what's happening. We basically have some traces from Hollywood, some logging from Hollywood itself. We're going to say handler started. That is basically our started function. First of all, we get the handle initialized, by the way, state is 10. Then we're going to start, and then basically here you could see the pit local handler, right? Because we are using right now the local engine, there is no networking involved. Although the library supports that, that's for later. First things first, right? That's that. So of course, that's fine. The next thing we're going to do is create a custom type, right? We're going to say increment state, for example. That's going to be a structure. Not increment state. We're going to say set state. And we're going to say the value is going to be a uint, right? And each time we're going to receive case set state, right? If we receive the message set state, we're basically going to say, let me copy this println thingy, handler received new state, just like this, and it's going to be a state, just like that. And we're going to say handler state is going to be message dot value, right? Just like that.
Stop taking meeting notes and let ClickUp AI Note Taker do it for you. It allows you to focus on your meetings, not
No need for this anymore. Okay, so that's that. How can we send messages to this process? You could send messages from the engine itself. You could also use the engine to send messages from another process, because we could have a player and a UI object or something, or a player, an enemy, or something else, and they could send messages to each other without the need of mutex. It's all pretty fine. And it's pretty fast. You could say, yeah, but you handling these messages one by one. I can handle, I don't know how, I think it was 10 million messages under a second, right? I will show you the benchmarks soon. I think it's even faster. I think it was under a millisecond or something. All right, so what we're going to do here, basically, let's make a loop real quick. We're going to say for x is 0, x smaller 10, and then we're going to say x plus plus, not sure why I'm using x, but it is what it is. Yes, we're going to say engine send me to this bit, right? We're going to give the bit, and then we're going to send a message, and that's going to be a set state here, and we're going to say that the value is going to be the uint of our iterator, right? That's that, and that's x. Yeah, that's fine. So that's what we're going to do. Let's run this again. Let's clear the screen real quick. Go run, boom. And you can see that the handler received a new state, 0, 1, 2, and yada, yada, yada. That's basically working perfectly fine. So you can make your custom messages, and these messages you can use to send them to your actors, and you can basically implement this case statement here. So each time there is a set state message, it's going to do exactly what you describe it to do, right? And you could have multiple messages, right? You could say, for example, type reset state, for example. Reset state is going to be a structure, and in this case, we don't need to have any value in it because we're going to reset the state, right? Maybe you could reset it to a certain value, that's true, but in this case, we're just going to reset it to 0. So how are we going to do that? Very simple. We're going to say case reset state. We're going to say that the state of the handler is going to be 0 here, and then we're going to say here, boom, received, just like this, reset state, and our state is this, and then we're going to do that basically after our loop here. It's so annoying that Vim basically doesn't give me some space beneath. Maybe I should install a plugin for that. So basically, we're going to loop 10 times. We're going to send a message, the set state message is basically just increments in this case, and then we're going to say, for example, send me to the same pit, but send me the reset state message, just like that, right? So boom, let's run this again. Voila. You can see we are setting our state, and by the end of our loop, we're going to reset the state, just like that. And you can have multiple messages, right? I'm using Actor Model in production, the company where I work for, and we are basically having hundreds of messages, different things, right? That's getting sent daily in production, right? So that's that. Basically, what I'm going to show you real quick is You see, if we make it, if we make this go, right? If you do go here, go send, right? And we're gonna run it again. Let's clear the screen in the blink of an eye, and then we do this again. Nothing happens, right? There is no race condition, there is no nothing, because it's the actor model. Of course, if you do this, right, go send, these messages will not come in order. Right? That's completely fine. But we have no race conditions. That's the important stuff, right? You can never have this synchronized, right? If you do that, that's impossible, right? But it's safe, right? Each time you're gonna handle your set state or reset state, you're going to have your exact value. It's not gonna. There is no concurrent read or writes, right? That's the point to take away. 70 minutes, right? So basically, what I'm going to show you is how fast it's going to be. Actually, what can I do? I can do... Shit, it's in Hollywood itself. That's fine. Let me open up boom, this thing here. Let me show. I think I have this benchmark somewhere here, right? Yeah, so you could see it's going to... This is 100 million. This is basically... This is 10 million messages in under a second, right? That's basically pretty impressive. If you tell me, right? It's probably the fastest out there. But it doesn't matter, right? It works, and that's the most important thing. So that's basically a very briefly overview on the actor model. The thing you need to take away with this is very commonly used for highly concurrent distributed systems. Think about game servers, RTS, games, trading engines, and all that shenanigans. And an actor is basically just some kind of an entity that acts upon messages it receives from other entities / actors, right? And it handles these messages. It has a mailbox, and it basically will queue up all these messages, and it will process these messages one by one.